Okay, everybody, we're going to finish up graphing today. So if you remember, we talked last class about graphing in vertex form, and today I want to talk about graphing in standard form. So first off, let's talk about why we have two forms. So I think vertex form is easier to graph. The vertex is already there for you, it's less work. So I think vertex form is easier to graph. However, standard form is going to be better for solving. So if you remember, we talked about finding those x-intercepts on our graph. Well, we sometimes want to find those x-intercepts algebraically, and that's what's going to happen after this section for the rest of the chapter. So it's helpful to have a form that's easy to find those x-intercepts, and standard form is usually that form that they give the equation to us to help us find those solutions. So we also have to know how to graph in standard form. Even though it's not easier to graph, it is better for solving for those x-intercepts. All right, so what is standard form and what does it look like? Standard form is the form of y equals ax squared plus bx plus c. So notice there's no parentheses here. That's kind of how you can visually tell the difference between the two. Vertex form has the parentheses and standard form does not. And you'll see there's three important values in standard form. The a is the same a value that we had in vertex form. So it's that coefficient for the squared term, and it's still going to tell you if your parabola is open up or open down, and if your parabola is skinny or wide. But other than that, it really isn't going to help us a whole lot in terms of graphing. The C value is going to be important for us. It's going to tell us our y-intercept. And why is that helpful? Well, we can identify the y-intercept and graph the y-intercept really quickly. So when you have the y-intercept, if you can put that on your graph, that could be really helpful when you're trying to graph. All right, so what else is important about standard form? Well, what's important is how do you find the vertex? Because that's the point, is we want to know how to find the vertex. So once we have our vertex form, our standard form, we can find the vertex by going through and using the formula x equals negative b over 2a. So you can see that formula right here, x equals negative b over 2a. That's going to be what we use to help us find the vertex so that we can graph in standard form. Then when we go through and try to find that vertex point, we're going to use that negative b over 2a value. That's going to be our x-coordinate. And then we're going to have to plug that in and find its function value, or the y value, of that same x value. So you'll see my y-coordinate says f of negative b over 2a because I'm going to take the function value of whatever value I found for x. And you'll see that in our steps. All right, so what are those steps? Here you go. Our steps are, first, we're going to find that x-coordinate using the x equals negative b over 2a formula. Then we're going to find our y-coordinate by taking our answer from step 1, the x value, and plugging that into the equation. That's going to give us our vertex point, steps 1 and 2. Then we're going to graph that vertex and our axis of symmetry. Remember that vertical line. Then we're going to graph our y-intercept if we can, if it's on our graph, or we're going to pick another point just like we did for our vertex form, and then we're going to reflect that new point over the axis of symmetry to make that third point that we need to make that U shape. All right. Here's going to be our example. You're going to have to draw this off to the side. So let me go ahead, first of all, and replay this whole thing so you have time to draw it out. So don't forget, you can replay your writing by going to the View menu and then the Replay feature and drawing a box around your particular problem or notes that you want. And so here is the problem. Let me go back real quick. So there's our problem that we want to draw. Or to graph. So I would suggest, because you don't have this, that you pause the video, write down your example, and draw a little XY graph. It doesn't have to be perfect, but make it just kind of off to the side here. So pause the video and draw your example out real quick, and then when you're ready to start back up, go ahead and play. Okay, so when we get ready to graph in standard form, one of the first things we need to figure out is what is A, what is B, what is C. So in this particular equation, A is 2, B is negative 8, and C is 6. So our first step after we found our a, b, and c is to use the equation x equals negative b over 2a to help us find the x-coordinate of our vertex. So I'm going to go through and I'm going to plug in my b value at negative 8 and my a value at 2. That gives me x equals negative 8 times or over 2 times 2. Remember, it's negative b, and b was already negative, so that's 2 negatives in the numerator. All right, negative 8 is positive 8, and 2 times 2 is 4. Divide that, and you get 2 for your x coordinate. So I know part of my vertex is 2 comma something. The question is, what is that something? Well, that's what we're going to do in step 2. So here's step 1. I went through and found the x value with that formula. Step 2 is to take that x value, that 2, and plug it in everywhere there's an x in my equation so that I can figure out what y is. So you'll see that I go through and I take my 2 and plug it in for x up here and in that second x spot as well. So when I write it out, it says y equals 2 times my x value of 2 squared minus 8 times my x value of 2 plus 6. And then I'm going to get my calculator out and I'm going to type that whole long thing in and I'm going to figure out what y is equal to. So I'm just going to do all my order of operations, squareds, multiplication, and then adding and subtracting. And it turns out that y ends up being negative 2. So there's step 2. I had to find my y value. So I found my x value, then I had to find my y value. That gives me my vertex point. So my vertex point is 2 comma negative 2 for this particular problem based on that equation in standard form. Also, remember your axis of symmetry is that vertical line through your axis or your vertex. So the axis of symmetry is going to be x equals 2. All right, so if we graph our vertex at 2, negative 2, and the axis of symmetry, that gives me my vertex point in purple there, and my axis of symmetry vertically through that dot. All right, that was a lot of work to do the vertex. You can see why vertex form is easier for that part. But now comes the easy part, and we're going to go ahead and find another point. And if you remember, I talked about that c value or that y-intercept value. And if I can find that y-intercept value and graph it on my graph, then it's nice and easy. So I'm going to go through and I'm going to look for my c value, which in this particular case is 6. And then I'm going to graph that on my y-axis. So I'm going to put a dot at 0, 6. Oops, go back one step. So there's my y-intercept point at 0, 6. Now all I have to do is take this point and flip it over that y axis of symmetry line and move it to the other side. So right now it's 2 spaces away from the axis of symmetry. So its reflected point has to be 2 spaces away as well. So there's my new value right there. And then you can make your nice little U shape out of that. All right. So step 5 is that reflected point. Thanks. Okay, so that's how you graph in standard form. You can see that the first couple steps are a little more involved, but if you have that y-intercept point and you can graph it on there, then it's nice and easy to graph that second part. Okay? All right, so let's get rid of that replay feature. And then let's talk about changing from vertex form to standard form. So occasionally you'll need to go from vertex form to standard form, like I said, so that you can graph or solve. And we already know how to do that. It just requires us to do a little bit of polynomial multiplication. So we're going to have to FOIL, or we're going to have to use one of those special cases, if you remember them, to help you expand that vertex form. So here are the steps to do that. First, you would multiply your binomial and get a longer trinomial inside the parentheses. Then we're going to distribute that a value to all the terms in the parentheses. And then finally, you'll combine any like terms you might have. So you can see in my example, I started out with a vertex form here. Y equals negative 3, x minus 1 squared minus 1. I got to get rid of this parentheses first. So I do that by multiplying x minus 1 times x minus 1 using FOIL or special cases. So if I do x minus 1 times x minus 1, I get x squared minus 2x plus 1. That's in the parentheses now. Then I'm going to take my negative 3 and I'm going to distribute it to all those terms. So I get negative 3x squared plus 6x plus, or minus 3. That negative 1's just kind of hanging out on the end there for a while. And then finally, I want to combine those two like terms at the very end, and that's how I get my minus 4. So negative 3x squared plus 6x minus 4 is the same standard form that I get for this vertex form graph. So if I were to graph both of those, I will get the exact same picture because those are the same form or two different forms of the same graph. Okay? So you can do that too because we know how to multiply binomials and we know how to distribute and we know how to combine all our like terms for polynomials. So you should be able to change any vertex form to any standard form. Now going backwards, it's going to be much harder. So unless you can find the vertex, it's going to be a little more complicated. And so we'll talk a little bit more about that on Friday. All right, the last thing I wanted to talk about today is graphing on your calculator. So remember, you can graph any quadratic on your calculator, just like you can graph any equation on your calculator. You press y equals to enter your equation, type in the equation, do zoom 6 if you want to get your standard window, or you can use the window button to change your window, and then you graph, and I'll show you one of those in just a second. But the other cool thing about your calculator is it can help you find that vertex point, either the minimum or the maximum, and it can help you find the zeros on your calculator. So I want to show you how to do one of those real quick. So if you get your calculator out, whoa, come back, sorry. Oh, my mouse is being really crazy today. All right, we're just going to do this. There we go. Sorry. All right, technical difficulties while I was trying to open my calculator. My apologies. All right, so here we are on our calculator, and if you press the y equals button, then you'll be able to type in not that crazy quadratic, or that was a quadratic, but it was a sine quadratic. So that was pre-calc. Let's type in an easy quadratic. Let's type in the one we did in standard form. So we'll type negative 3 parentheses x minus 1 parentheses squared minus 1. So under y1, you can type either a vertex or standard form. It does not matter. And then you're going to go to graph. And if it looks great, good. Mine is not looking that great. So let's go to zoom and then option number 6. There we go. And now I have a nice little graph. And then, so there's your graph if you needed to just look at it or see what it looked like, or maybe compare it to something. And then if I wanted to find out some information about this graph, then I could go to second and trace, which is really the calculate menu. And you can see the list here of all the things I can find. I can just find a random point on that quadratic. I could find some of those zeros if it crossed the x-axis, and I can find the minimum or the maximum. Now, if you remember the picture, the graph was open down, so in this case, I would be finding the maximum. So I'm going to pick option number 4. And when you do the maximum, you'll see way down here at the bottom, it asks you to kind of give it an area to look for that maximum. Where should I look, says the calculator. And so in this case, it says, where should I look on the left of the point you're trying to find? So if you think about your vertex being right there around the 1, x equals 1 amount, then anywhere on the left side of the equation, I can hit enter, and that will give me a marker to the left. And you can kind of see this little arrow showed up to tell me that was to the left of that point. Then down here, you'll see it changed to right bound. So I need to use my arrow key and go to the right of the vertex. So I'm going to go somewhere on the right side of the parabola. anywhere you want and hit enter again. And then you'll see a second arrow showed up. And your vertex should be in between those two arrows if you want the calculator to find that correctly. And then it says guess, and you're saying yes, yes, yes. Please look between those 2 points and find me the maximum. And now it'll tell you that your maximum is actually between 1 and -1. So you can go ahead and see that if I just make this a little smaller. There we go. So 1 and -1 down there is your maximum point or the vertex of this particular quadratic equation. So you can use your calculator to find that if you need to. Um, all right, so that's all I got for today as far as graphing in standard form and using your calculator a little. There's some graphing in standard form practice. Maybe you want to try to graph 1 or 2 on your calculator as well and just kind of figure out how to do that. And then we will practice more graphing on Friday. Thanks.